Hi, I'm Sam Roberts from Roberts Geospatial Engineering. Today I'm using ProRaster Scientific version 4.2.04, which you can find on the Microsoft Store. Today we're going to go through a process where we're going to create a very high resolution topographic map. I'm going to get that onto my phone so that I can use it when I'm out bushwalking in my GPS application as an offline map. So I'm going to take you through that whole process. So if you're out bushwalking or mountain biking these days, you'll take your phone with you. And your phone, of course, is a GPS. And if you have an application on your phone that operates as a GPS, then you can use your phone instead of taking some kind of dedicated GPS hardware. When I'm out in the bush, I use an application called HandyGPS, which you can get on Android and on Apple phones. The problem with using your phone is that the maps that it draws upon will be generally Google Maps. And as soon as you're outside of cell phone coverage and you've got no reception, then you will lose your maps. So number one problem is that you may have to generate offline maps before you leave. The second problem is that you might not be happy with the quality and the resolution and the information that you find in those standard Google Maps. So we're going to do better. We're going to use ProRaster to generate very high resolution topographic maps from LiDAR data that we've gridded in ProRaster Scientific. And we're going to get that onto the phone and use it as an offline map in HandyGPS. So I'm going to work a bit out of order here. I'm going to show you how to export first. I already have my algorithm. We'll go back to building that in a little while. But having saved my algorithm, I now come into Export Image. Brings up this image export dialog. And there are two possible choices here. So I've already made a video about exporting to XYZ OGC WMTS tiles. Now, HandyGPS uses exactly the same format. So I've got an option here for HandyGPS offline map. At the present time, that's exactly the same as the XYZ option. However, there is one additional step that you do need to take when you're outputting for HandyGPS, and that is you have to zip everything up into a zip file archive at the end of the process. And in future, ProRaster might do that for you, in which case you'd use this HandyGPS offline map option. At present time, it doesn't. So you need to specify your output folder. So I'm going to make a new folder. I'm going to call it HandyGPS Udo National Park. Select that folder. Then you can, in my case, I'm going to clip to a polygon. So I'm going to choose this Budo National Park Surrounds polygon, and it is actually the shape that you can see on screen. That's the algorithm already clipped to the polygon. And then you just set your resolution level. So when I'm creating these things, I generally go for a resolution of around 1/4 of a meter. Let me just explain here. You can see this pixel size reported here is about 29, almost 30 centimeters, where it says the true cell size is about 25 centimeters. That's because in the EPSG 3857 coordinate system, 1 meter is not 1 meter, except if you're exactly at the equator. Everywhere else, there's going to be a difference. So this pixel size is not really what it purports to be. The true cell size is more like about 25 centimeters. So I'll output at that resolution. However, for the purposes of demonstration, we'll make it a bit smaller. Hit the process button. Now it's going to output a whole bunch of PNG files out to a directory structure. So that's now done. So it's generated a directory called, we created this directory, HandyGPS, and then it's generated all of these subfolders. These are for the resolution levels, and in those subfolders it has another subfolder for each column, and in there you'll find all of your PNG files, and then there's this XML file right at the root. You use that to render what you've just created in ProRaster, just to check that you've got the right result. You then need to zip that up, so you can use Windows. I tend to use 7-zip, so add to HandyGPS blah 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 .zip. It'll create that file, and then that's the file that we're going to take across to our phone and use in HandyGPS. So we'll see how to do that in a minute. So let's build up our topographic map algorithm. So in this particular area, I have 2 LiDAR surveys. So let's have a look at them. So let's add a new algorithm for Raster Source. So I've got Central Coast LiDAR. Let me come in and change the color scale. Central Coast LiDAR, and then I've got add another layer, which is the New South Wales Marine LiDAR. So you can see it there, goes up the coast. So I want to use both of these surveys. So I want to basically merge these things together. So the first way that you might go about that is you might say, well, I'll create a raster source with these 2 surveys. So let's do that. So go into the raster source editor, and I'm going to add a new raster source. I'll call it Central Coast Combined LiDAR. So I'm going to add my files into my raster source. I'm going to drag and drop them from File Explorer. So I want to put them in the order of lowest resolution to highest resolution. My lowest is this Central Coast one, so I'll put that one in first. And then I'll put in my Marine LiDAR, and that goes on the bottom. So we want from lowest resolution or lowest quality to highest resolution and highest quality in this list. So I've hit OK. Now you can see that I have one raster dataset rendered, and let me use that color table. So now it looks seamless, but it's not seamless. We're actually rendering both of these rasters, and we haven't actually merged them in any way, shape, or form. And I can demonstrate that if I now add a contour layer, and I go into my component and I choose my Central Coast Combined LiDAR Raster Source. I'm going to turn this one off. Go into my contour. I always change these sizes a bit. Now let's zoom in somewhere and take a close look. You can see that when I zoom right in, I've got 2 contour lines everywhere. So where these 2 data sets overlap, I'm rendering both of them as contours. In other words, in the rendering engine, it's rendering both of those layers. If you render it as an image, well, one will overprint the other, and it kind of works out okay. But when you're doing a contour, that doesn't work, and you get duplicated contour lines, one from each data set when you're rendering. So the easy way to resolve that problem is to go into your merge simple join operation. Now we've already created our raster source, so we can select it. So that's our 2 rasters that we want to merge, and then I'll write that out to an MVR. This is a virtual raster. Hit OK. Now I'm doing a true merge operation. That's what it looks like. If I add in my contour layer, connect it to that merged raster data set, change those things like I always do, and now zoom in. You can see now that I only have 1 contour line. There's only 1 data set. So that's the LiDAR data set that we're going to be working with to create this topographic map. So let's build our algorithm. So I'm going to start with Google Maps. And what I might do is just rejig this so that we can see what we're looking at. I'm going to clip the algorithm. I don't need to, because I'm going to clip to the polygon when I export, and we've already seen that. To add clipping into the algorithm here is just double clipping. It's a waste of time, don't need to do it. But for the purposes of demonstration, I'm going to clip. So I'm going to clip by polygon instead of by raster, and I'm going to choose the polygon, which is not in the list, so I'm going to have to browse to it. Data, polygons, good eye surrounds, there it is. And turn that on. And now my map's clipped to that tiny little section. If I go zoom to that polygon, it will zoom in, and there's Google Maps clipped to that area that we're interested in. Now I want to drape this on my LiDAR. So I'll go to my intensity layer. I'm going to choose the raster that I created before, the virtual raster. This is my merged LiDAR data. I'll turn that on. And in my shadow, I'm just going to take off this specular highlight, which I don't want. So now I have my Google Maps draped on this LiDAR. We're getting both terrain. Sorry, catch up. We're getting terrain, and we're also getting bathymetry. So you can see the topography of the seafloor out here, as well as the topography of the national park and the surrounding area. Okay, so that's okay. Let's name our layer, because it's always good. Google Maps Draped. Now, I want some contours. So I'm going to add my contour layer. I'll go in and select merged LiDAR. And then, as I do every single time, and I must change this default, I'll change the width of the contours a bit. They're always a little bit too fat. I'm going to leave dropout on. Labels are okay as they are. I'm just going to leave it at that. But for the sake of consistency, we'll also turn on clipping. So I'm going to clip by polygon and select that polygon and then enable that. So now we've got our contours draped onto, overprinting Google Maps, which is draped on our hill shaded LiDAR data. And so you can see that as we zoom right in, we have very high resolution LiDAR topography that's showing us basically every single boulder and rock that's in the national park and every cliff line. Zoom back out to that polygon. Okay, the only other thing I'm going to do is I'm going to bring in now a little bit of the Google Imagery. And I don't want that to blow everything away, but I just want it in the background. So I'll add a layer for WebMap, Google Maps, Google Imagery. Again, I'm going to clip by polygon. I'm going to drape it on our LiDAR. And I'll just disable that highlight again. And I'll name this Google Imagery Draped. And I'll name our contour layer LiDAR Contours. Oops. And I should name my algorithm. So I'll call this UDI National Park Topographic Map. How did I go? Okay. Now, I can't see anything, so I need to move this down. Move it down one more. Now it's sitting underneath the Google Maps, and it's been completely blown away by the Google Maps. So we need to introduce some opacity. Let me go back up to the algorithm layer and to the color, and just make sure that my blending rule is set to blend. Now I can go to my Google Maps layer, and I'll bring down this opacity a bit, say half. And now we can see if we zoom right in, we just have to wait for it all to catch up. And it's being a bit slow. Here it comes. So now we can see that we have Google Maps. We can see the streets. We can see the paths that are in the national park and so forth. We also have our imagery. We can see the houses, which is useful when you're on the edge of the park. Let me go into swapping. We'll just flip this. So there's my contours, there's my Google Maps, here's my Google Imagery. So what I might do is just fiddle around with the colors in the Google Imagery. So I might brighten up the shadows. So I've gone to the color. So in the layer, I go to the color control, and there's an option here to brighten shadows. So I just put in a scaling factor, 0.3, and our power factor is 2. I'll just leave that as is. And you can see that some of the darkness has been taken out of some of these shadowed areas where we're in the cliff, where we're in the cliff line. You can also darken the highlights. So the shiny white roofs, if I put in say 0.2, you can darken those roofs so that they don't blast you. And then what I like to do often is bump up a bit of the saturation. Remember that this is going to be faded out because we've got other layers on top of it. So you bump up the color saturation, and you can see more contrast in that imagery. So I'll disable my swapping now, and here's our algorithm. So we have 3 layers. We've got our contours on top. Then we have our Google Maps, which is draped on the LiDAR data. And then we have Google Imagery, which is draped on the LiDAR data. And we have some opacity on the Google Maps. Not variable opacity, just a broad layer opacity so that we can see through to the imagery. Gee, it's really thinking about bringing in that Google data. My wife's probably on the internet. And then we have some color modulate. We've played with the color in the Google Maps to bring it up and make it a little bit more punchy. So let me zoom to my polygon. Now I need to save my algorithm. I'm going to do save as. See, temp, Woody National Park. Yeah, that'll do. Now I'm ready to export. And we've already gone through that stage. So the next step is to get it onto the phone. Right, so I regenerated that output to the XYZ tile format at that 25 centimeter resolution. So I now have, and then zipped up the entire folder and all the PNG files and everything in it. And that's a 1.8 gigabyte zip file. Now I'm going to copy that across to the phone. So I've plugged in my phone. You then need to go to your USB tethering. This is on Android, and make sure that you're tethered for file transfers. So in your internal storage, go to your downloads folder and copy your zip file containing the folder and everything in it. And it's very important that you have that folder into this downloads file. Then you'll be able to access that from HandyGPS. But before we go to HandyGPS, I'll just show you where you can find all your HandyGPS files. So there's a HandyGPS directory, but you won't find them in there. You need to go to the Android directory, go into the data directory, then you'll find binaryearth.handygps. And then you'll find the files directory. and in there you'll find a map tiles folder. And that's where the folders that get unzipped will go. So you can see that I've got 5 offline map folders here with all those different things in it. So you can come in via this mechanism and manage your offline folders. You can delete them from here if you want. So let's now have a look at HandyGPS on the phone, and we'll see how to unzip this file and select it as your offline map. Android phone, I'm going to select HandyGPS, go into the map, and then drop down the button at the top and go Manage Offline Maps. I currently have an offline map active, so I'll turn that off. Now press the button Import Map from Zip. And here's my new zip file that I've just added. And it's going to unzip that. Now, it might take a little while. Something like 1.8 gigabytes is fairly big. When we first tested this a few months ago on an older version of Android, it took days to unzip it. But it's much better now on the newer versions of Android. So if you've got an old Android, you might have trouble with this kind of thing. I should also point out that you need the very latest version of HandyGPS to be able to do this. So it has selected it, and now you can see that if I come down here, here is my offline map. I'll just go to Layers, and I'll turn off that Google map. So we just have, there's my track map from a walk that I did yesterday. You can find that on YouTube. If we zoom right in, you can see that we have this very high resolution topographic map. So just as a final summary, let me remind you that you can test to make sure that your map is working by going into the output directory and getting this little XML file and drag and drop that onto ProRaster. Zoom to the area that you're interested in, that you've generated the map, and there it is. So this is rendering that XYZ file. So you can test and make sure that the resolution is suitable and that everything's come out as expected. And you can just do that straight through ProRaster. So thanks for watching. Our next video will be similar exercise, but for the Warrumbungles, and hoping to do a field trip out there to go and explore some interesting features that you can see in the LiDAR, but don't appear on any topographic maps.